Welcome to MWN.com. Dr. M.Wilson is happy to welcome all to this session. Greetings from MWN.com. Dr. M.Wilson, author, publisher, professor of commerce and management, and formerly vice principal and head of Department of Commerce, Nagarcoil, is delighted in presenting this session. Thank you. Please subscribe the channel MWN.com. 2. Chapter 12. Analysis of Time Series. The arrangement of statistical data according to the time of occurrence is called time series. It helps to find out the variations in the values of data due to changes in time. For example, the annual production of tea in India, sales of a company for various periods, export of coffee from India for various periods, etc. are data related to time series. Meaning and definitions. According to Werner Z. Hirsch, time series is a sequence of values of some variates corresponding to successive points in time. Yalun Cho defined time series as a collection of readings belonging to different periods of some economic variable or composite of variables. Hence, time series means the data related to successive period of time. Importance of time series. 1. It helps for understanding past behavior. Since time series is based on the data related to past years, it is possible to understand the changes took place in those periods related to the particular phenomenon. It helps to know about the causes and circumstances of the changes in the past years. 2. It facilitates for forecasting and planning. It helps to project about the future and facilitates to plan about various activities in future. The businessmen, the government and social organization can take proper decisions about the future period, with the help of time series. Components of time series. The factors which changes in the value of variables in different periods of time are called the components of a time series. They are classified as a trend, B, seasonal changes, C, cyclical changes, and D, irregular or erratic fluctuations. 1. Trend. The changes of a phenomenon over a long period of time is called trend. The longer period depends upon the nature of the study or nature of the data. Longer period may be few years, or decade, or even centuries of time. The significance of trend is greater when the period of time is very longer. It is possible to eliminate the seasonal and cyclical variations if the period is very longer. For example, if the price level of agricultural commodities for a very short period, say 5 years, is analyzed, the prices might have been decreased or increased over the period. If the data are analyzed for a longer period, say 20 years, then it is possible to know the general trend of increasing the price level. Hence, trend may be considered as an accurate measure for knowing the character of a phenomenon over a period of time. 2. Seasonal variations. Changes of variable due to seasons like winter, summer, festival, etc. are called seasonal variations. It is measured for one calendar year. The business and economic activities mostly vary due to the natural factors and man-made convention. Natural factors are like rainfall, winter, summer, etc. Man-made conventions are like festivals. There is demand for woolen cloths and hot drinks during the winter season. But in summer there would be a heavy demand for cool drinks, air conditioners, etc. In festival season the demand for clothes, sweets, etc. are greater. The study about the seasonal variations helps for short-term planning for businessmen and economists. It is possible to plan the production of a company according to the seasonal fluctuations. 3. Cyclical variations. Changes of variable due to business cycle are called cyclical variations. Most of the economic and business activities follow the periods of business cycle. They are I, prosperity, E, decline, E, depression, and IV, recovery. After recovery, the prosperity stage takes place. At prosperity period there will be more economic activities. There will be high demand, sales, and it gives high profit for the companies. There will be low economic activities in decline stage. The demand for the products decreases due to low income of people. Profit declines during the declining stage and gives heavy loss for the company. Then the decline stage tends to reach depression. In this stage the demand, production and income are at very low level. Companies tend to incur heavy losses. Appropriate measures during this period help for the gradual improvement in the economic activities. It is called recovery stage. During this stage the demand and income started growing. Companies gradually recover from the loss position and starts giving low profits so as to reach a prosperity stage. 4. Irregular movements. It is otherwise called as random or erratic or unpredictable variations. The changes which could not be predicted is called irregular movements. Irregular movements are like changes in technology, war, famine, flood, strike, etc. The business and economic activities will be affected unexpectedly due to the irregular movements. Usually, the effect of irregular movement exists only for a very short period. Mathematical model of time series. There are two types of mathematical model for time series. They are 1. Multiplication model. 2. Addition model. 1. Multiplication model. According to the classical time series analysis, any particular observation in a time series is a product of trend, seasonal, cyclical and irregular movements. It can be represented as O equals TXSXCXI, where O denotes original data, T denotes trend, S denotes seasonal variations, S denotes cyclical variations and I denotes irregular movements. 2. Addition model. In additive model, particular observation in a time series is the sum of the trend, seasonal, cyclical and irregular variations. It can be represented as O equals T plus S plus C plus I. Example for mathematical model of time series. In multiplicative model S and I are represented in decimal points. In additive model S and I are represented as quadratic variations. E.g., in multiplicative model, if T equals 500, S equals 1.5, C equals 0.7, I equals 1.2. O equals 500 by 1.5 by 0.7 by 1.2 equals 630. In addition model, if T equals 500, S equals 110, C equals 70, I equals minus 45. O equals 500 plus 110 plus 70 to 45 equals 635. Measurement of secular trend. The following are the important methods of measuring secular trend. 1. Graphic method. 2. Semi-average method. 3. Moving average method. 4. Method of least squares. Graphic method. It is otherwise called as freehand method. Graphic method is the simplest method for measuring trend. The following are the procedures in this method. I. The original data should be plotted on a graph paper. E. The plotted lines should be joined to give a curve. E. A straight line should be drawn carefully through the middle area of the curve. On the basis of the nature of the curve, the straight line will either takes upward or downward position. This is called trend line. Merits. I. It is the easiest method of measuring trend. E. This method is more flexible than any other methods for measuring trend. E. In addition to the straight line, it also gives the picture of the movement of data. Demerits. I. It is possible to draw different trend lines in this method. E. The trend line under this method will not accurately project the future. E. If the person draw the line is unskilled, then the trend line will not be correct. In illustration 1, it is required to fit a trend line to the data related the production in a factory. 9 years data is given. It would be plotted in a graph by considering x-axis is year and y-axis is production. Semi-average method. In this method, all the variables should be divided into 2 equal parts and averages of these 2 equal parts are to be calculated. If the total numbers of observations are an odd number, the middle value should be eliminated. The 2 averages are to be plotted in a graph. X-axis represents time and y-axis represents value of variables. In the x-axis, the midpoints of the periods of each average should be identified. The values in y-axis corresponding to the points noted in x-axis should be plotted in the graph. Then the 2 points plotted in the graph should be joined so as to get a straight line. This line is called the trend line. The line should be extended backward or forward to know the past value or to predict the future value. Merits. 1. It is a simple method to know the trend. 2. It is an objective method of measuring trend. The trend line will be the same, though it is drawn by different people. Demerits. 1. It is based on straight line relationship whether such relationship exists or not. 2. The character of a phenomenon in future could not be accurately estimated in this method. 3. It is subject to the limitation of arithmetic mean. In illustration 2, it is required to fit a trend line through semi-average method for the data presented here. Solution. The 8 observations related to years from 2012 to 2019 can be grouped into 2 parts as 20, 27, 32, 39 and 45, 50, 53, 60. Hence, the semi-averages are 29 and 52. Rupees in thousands. It would be plotted in a graph by considering x-axis as year and y-axis as production. In illustration 3, it is required to draw a trend line by semi-average method for the data presented here. Solution. The 7 observations related to the 7 years can be grouped into 2 parts, by leaving the middle value, i.e., value for the year 2016. Hence, the 2 parts are 25, 37, 43 and 60, 67, 77 and the semi-averages are 35 and 68 rupees in thousands. It would be plotted in a graph by considering x-axis as year and y-axis as production. Moving average method. This method is a logical extension of semi-average method. In this method, a series of successive averages should be calculated from a series of values. Averages can be taken from overlapping periods. Moving averages may be calculated for 3, 4, 5, 6, or 7 yearly periods. The moving average trend will be a straight line, if there is regular movement of variables. It will be a curve, if there is irregular movement due to business cycles or seasonality. The moving averages can be calculated as follows. The formula for 3 yearly moving average is well presented here. When calculating the second moving average, first variable should be left and second, third and fourth variables should be taken for average. Like that, others should be calculated. In illustration 4, it is required to compute 3 yearly moving averages. 4 columns table should be prepared. In first 2 columns, values is given in the illustration should be written. In third column, 3 yearly moving total should be calculated. For example, 21 plus 25 plus 30, then 25 plus 30 plus 36, etc. The values should be written at center for which total has been calculated. In the last column, average of third column should be calculated, that is, the values should be divided by 3. In illustration 5, it is required to calculate 5 yearly moving averages. 4 columns table should be prepared. In first 2 columns, values is given in the illustration should be written. In third column, 5 yearly moving total should be calculated. For example, 15 plus 20 plus 27 plus 33 plus 37, then 20 plus 27 plus 33 plus 37 plus 42, etc. The values should be written at center for which total has been calculated. Hence, for the first value, it is corresponding to 2018. Like that, all values should be written. In the last column, average of third column should be calculated, that is, the values should be divided by 5. In illustration 6, it is required to calculate 7 years moving average. 4 columns table should be prepared. In first 2 columns, values is given in the illustration should be written. In third column, 7 yearly moving total should be calculated. For example, 12 plus 17 plus 20 plus 26 plus 32 plus 40 plus 47, then 17 plus 20 plus 26 plus 32 plus 40 plus 47 plus 54, etc. The values should be written at center for which total has been calculated. Hence, for the first value, it is corresponding to 2018. Like that, all values should be written. In the last column, average of third column should be calculated, that is, the values should be divided by 7. Calculation of moving averages for even periods. Moving averages may be calculated for the even periods also. The placement of the moving average in a particular year is not possible when moving averages for even periods like 2 years, 4 years, or 6 years are calculated. It lies between 2 years, say, between third and fourth years. Hence, to place the averages to respective years, moving average for 2 years for the calculated moving averages for the even years should further be calculated. In illustration 7, it is required to calculate 4-year moving average. 6 columns table should be prepared. In first 2 columns, values is given in the illustration should be written. In third column, 4 yearly moving total should be calculated. For example, 15 plus 20 plus 27 plus 35, then 20 plus 27 plus 35 plus 40, etc. The values should be written at center for which total has been calculated. Since it is even number, it lies between 2 years. In the first case, hence, for the first value, it is corresponding to 2011 and 2012. Like that, all values should be written. In fourth column, 4 yearly moving average should be calculated by dividing the values in the third column by 4. These values are also not fit into a particular year. Hence, centered moving total and centered moving averages should be calculated to fix the values corresponding to a particular year so that there may not be any difficult for drawing a graph. It can be calculated by totaling 2 values in the fourth column, like 24.3 plus 30.5 equals 54.8. It fits in the year 2012. Like that, all values should be calculated. In the last column, average of fifth column should be calculated, that is, the values should be divided by 2. In illustration 8, it is required to calculate 6 yearly moving average and to plot them in a graph paper. 6 columns table should be prepared. In first 2 columns, values is given in the illustration should be written. In third column, 6 yearly moving total should be calculated. For example, 11 plus 17 plus 22 plus 26 plus 33 plus 37, then 17 plus 22 plus 26 plus 33 plus 37 plus 44, etc. The values should be written at center for which total has been calculated. Since it is even number, it lies between 2 years. In the first case, the value it is corresponding to 2017 and 2018. Like that, all values should be written. In fourth column, 6 yearly moving average should be calculated by dividing the values in the third column by 6. These values are also not fit into a particular year. Hence, centered moving total and centered moving averages should be calculated to fix the values corresponding to a particular year so that there may not be any difficulty for drawing a graph. It can be calculated by totaling two values in the fourth column, like 24.3 plus 29.8 equals 54.1. It fits in the year 2018. Like that, all values should be calculated. In the last column, average of fifth column should be calculated, that is, the values should be divided by 2. Merits. 1. It is the simplest method of measuring trend. 2. It is flexible in nature. The calculations will not change due to addition of few variables. 3. It eliminates cyclical fluctuations due to overlapping of data for various periods. 4. It will give same result even if it is attempted by many people. 5. It is suitable even if the data of a series is very irregular. Demerits. 1. Trend values cannot be calculated for all the years in this method. For example, in 5 yearly moving averages, 4 years are left out, i.e., 2 years in the beginning and 2 years at the end. 2. There is no mathematical formula for selecting the period for calculating moving averages. 3. It will not completely eliminate the cyclical fluctuations. 4. It is of little use in forecasting since it is not represented by mathematical function. Least square method. This is a popular method of obtaining trend line. In this method, the trend line is calculated through a straight line equation. This method is called the method of least square since the sum of the squares of the deviations of the actual and computed values are least. The trend line obtained through this method is called the line of best fit. The trend line is represented as yc equals a plus bx, where yc denotes the trend values, a and b are constants, and x denotes time. A represents the y-intercept, or the value of y variable when x equals 0, and b denotes the rate of change in y variables which is associated with a change of 1 unit in x variable. B also represents the slope of the line. The value of a and b can be calculated by solving the following two normal equations mentioned here. A represents the arithmetic mean of y, and b represents the rate of change. When deviations are taken from the middle year as origin, sigma x would be 0, for the odd number of years. It is also possible to get sigma x equals 0 for the even number of years when the origin is placed midway between two middle years. For even number of years like 2014, 2015, 2016, 2017, 2018, 2019, the origin should be fixed in between 2016 and 2017 is 2016.5. Hence, the deviations would minus 2.5, minus 1.5, minus 0.5, 0.5, 1.5, and 2.5. It is required to calculate trend values by the method of least squares and to calculate the production in 2029 and 2034. 6 columns table should be prepared. In first 2 columns, values is given in the illustration should be written. In third column, deviation from 2021 should be calculated. Value for 2021 is 0. Hence before that 3 minus values and 3 positive values after 2021. This is due to 1 year difference between 2 years. In the fourth column, values in second and third columns should be multiplied and written. In the fifth column, square of values in third column should be calculated. In the last column, trend values is calculated and the workings should be written. The total of it equals to the total of the second column. Trend values are calculated through the equations. Sigma y equals na plus b sigmax. 273 equals 7a plus 0, hence, a equals 280 by 7 equals 40. Sigma x y equals a sigma x plus b sigma x square. 181 equals 0 plus bx 28, b equals 196 by 28 equals 7. Hence, yc equals a plus bx, that is yc equals 40 plus 7x. Trend values are calculated through the equation for respective x values. The calculations are well presented here. Hence, the production in 2029 and 2034 can be calculated by taking x values is 8 and 13, that is 2029 minus 2021 equals to 8 and 2034 minus 2021 equals to 13, and the values are as follows. Calculation of straight line trend for even number of observations. In illustration 10, it is required to fit a straight line trend through the method of least square. 5 columns table should be prepared. In first 2 columns, values is given in the illustration should be written. In third column, deviation from 2021 and 2022 should be calculated. Value for 2021 is minus 0.5. Hence before that 2 minus values that is minus 1.5 and minus 2.5 and 3 positive values after 2021 that is 0.5, 1.5, 2.5. This is due to 1 year difference between 2 years. In the fourth column, values in second and third columns should be multiplied and written. In the fifth column, square of values in third column should be calculated. The sum of the values in last 4 columns should be calculated. Trend values are calculated through the equations. Sigma y equals na plus b sigmax. 175 equals 6a plus 0, hence, a equals 175 by 6 equals 29.2. Sigma x y equals a sigma x plus b sigma x square. 138.5 equals 0 plus b by 17.5, b equals 138.5 by 17.5 equals 7.9. Hence, yc equals a plus bx, that is yc equals 29.2 plus 7.9x. Trend values are calculated through the equation for respective x values. The calculations are well presented here. Measurement of seasonal variations. The economic and business activities are mostly affected by seasonal variations. It is not possible to identify the seasonal variations when the data are expressed as annually. It can be identified only when the data are expressed monthly or quarterly. For example, the sales of cool drinks for hot seasons are greater than the sales in other seasons. For such kind of products, comparison of sales of different years won't show much difference. It also won't explain the seasonal variations. Hence, the value for various seasons for different years should be calculated to find out the seasonal variations. Methods of measuring seasonal variations. The important methods for measuring the seasonal variations are as follows. 1. Simple averages method. 2. Ratio to trend method. 3. Ratio to moving average method. 4. Link relative method. Simple averages method. This is the easiest method for calculating seasonal variations. This method can be applied to monthly, bi-monthly, quarterly, half-yearly, etc. In this method, first of all, the individual totals for all the same months or period of all the given years should be calculated. Example, if 4 years data are available for 12 months and, then the 12 months total for all the 4 years should be obtained. Then the average monthly total should be calculated by dividing the totals by the number of years. In the example, it should be divided by 4. Then the averages of the average of 12 months so obtained should be calculated. To ascertain the seasonal variations, average of each month or period should be divided by the average of the averages, and then it can be multiplied by 100. The correctness of the answer can be verified by totaling all the seasonal indices so calculated. It should be divided by the total no of periods, months or weeks, etc. If the value is equal to 100, then the value of the seasonal indices are correct 1. In illustration 11, monthly sales of product X in a company for 4 years are given. It is required to calculate seasonal variations through simple average method. 8 columns table should be prepared. In first 5 columns, values is given in the illustration should be written. In sixth, total for all years of each month should be calculated. That is 5 plus 4 plus 9 plus 6 equals 24. Like that, all values should be calculated. In seventh column, average of the values in column 6 should be calculated. That is 24 by 4 equals 6. Like that, all values should be calculated. Then total of average should be calculated. That is equals 71. Then total of the average should be divided by 6, that means 6 years, to know the average of the average. That is equals 71 by 6 equals 11.83. Seasonal index should be calculated as 6 by 11.83 into 100 equals 50.71 for January. Like that, for other months should be calculated. In illustration 12, it is required to calculate seasonal index by simple average method. 5 columns table should be prepared. In the 5 columns, values is given in the illustration should be written. All calculations are shown in rows. 3 rows should be added. Of that, in the first row, total of each quarters should be calculated. That is 10 plus 13 plus 7 plus 5 plus 15 equals 50. Like that, all values should be calculated. In the next row, average of it should be calculated. That is equals 50 by 5 equals 10. Like that, all values should be calculated. In the last row, seasonal index should be written on the basis of the calculations done in workings. First, average of average should be calculated. The calculations for seasonal index are well presented here. Average of average equals seasonal index for the first quarter equals Seasonal index for the second quarter equals. Seasonal index for third quarter equals. Seasonal index for the fourth quarter equals. The above table can also be represented through another method also, which is well presented here. Merits. This method is a simple and easiest method of measuring seasonal variation. Demerits. The effects of cyclical variations could not be exactly calculated in this method. Ratio to trend method. This method is an improvement over the method of simple average method. It assumes that seasonal variation for a given month is constant fraction of trend. Under this method, the trend is eliminated when the ratios are calculated. This method isolates the seasonal factors as follows. T into S into C into I divided by T equals S into C into I. Where T trend, S, seasonal factor, S cyclical factor, I, irregular factor. The steps for calculating seasonal index under this method are as follows. 1. First of all, the trend values should be calculated through the method of least squares. 2. Then, divide the actual data for all periods, months or quarter by the corresponding trend values. These values must be multiplied with 100. These values are free from trend. 3. The next step is to free these values from irregular and cyclical movements also. The values so obtained, for the various years of the periods, months or quarters, should be averaged either by mean or by median. 4. The sum of the average values of the periods should be equal to 1200 if the periods represent months. It should be equal to 400 if the periods represent quarters. If it is not equal to 1200, then each average value should be multiplied by 1200 divided by 12 when the periods represent months. If it is not equal to 400, then each average values should be multiplied by 400 divided by sum of the four values when the periods represent quarters. In illustration 13, it is required to calculate seasonal index on the basis of ratio to trend method. Production for 4 years in quarterly basis are given. 7 columns table should be prepared. In first column, year should be written. In second column, total yearly production should be written. That is 20 plus 25 plus 30 plus 35 equals 110. Like that, all values should be calculated. In the third column, average yearly production should be calculated. That is 110 divided by 4 equals 27.5. Like that, all values should be calculated. Then in the fourth column, deviation from X should be calculated by taking middle values is minus 0.5 and 0.5 for 2022 and 2923. Hence for 2021 minus 1.5 and for 2024 1.5. In the fifth column, product of third and fourth columns should be calculated. In the sixth, X square should be calculated. Trend values are written in seventh column as calculated in the workings. Y equals A plus BX. It can be derived through the equations mentioned here. On the basis of it, A and B values can be calculated. Hence, Y equals 40.63 plus 13.44 Y. Calculation of yearly trend values. Y21 equals 40.63 plus 13.44 minus 1.5 equals 20.0 equals 20. Y22 equals 40.63 plus 13.44 minus 0.5 equals 33.8 equals 34. Y23 equals 40.63 plus 13.44, 0.5 equals 47.5 equals 48. Y24 equals 40.63 plus 13.44, 1.5 equals 61.2 equals 61. Total equals 162.5. Calculation of quarterly trend values. Quarterly increment equals 12 quarters equals 3. E.g., trend value for 2016 equals 20. It is considered as central value which lies between second and third quarter. Hence, for second quarter it is less for 50% of the increment of 3, i.e., 1.5. When added with 20, the value for third quarter 20 plus 1.5 equals 21.5 will be derived and deducted with 1.5. The value for second quarter 21.5 equals 18.5 will be derived. Difference between each quarter will be 3. Trend values for 2 quarter equals 23 halves equals 21.5 equals 18.5. Trend values for 3 quarter equals 20 plus 3 halves equals 20 plus 1.5 equals 21.5. Trend values for I quarter equals 18.53 equals 15.5. Trend value for IV quarter equals 21.5 plus 3 equals 24.5. Like that, for the year 2022 is 34 1.5 equals 32.5, 34 plus 1.5 equals 35.5 can be derived for second and third quarter, and for first and fourth quarters the values are 32.53 equals 29.5 and 35.5 plus 3 equals 38.5 respectively. Like that, for the other 2 years should be calculated. The quarterly trend values are stated as follows. The following table is prepared a percentage of actual value divided by trend values. For example, the value for first quarter of 2016 is 2015.5 x 100 equals 129. Quarterly values is percentage of trend values are well presented in the table. Total averages equals 86.2 plus 90.5 plus 117.2 plus 141.5 equals 435.4. Since the total is not equal to 400, there is a need for adjustment. It can be done by multiplying each average by 400 435.4, i.e., for first quarter is 400 435.4 by 86.2 equals 79.2. Hence, the total equals 79.2 plus 83 plus 107.8 plus 130 equals 400. Merits. It is more rational method than other methods of calculating seasonal indices. This method will not exclude the extreme values. This method can be applied even for the calculation of trend values for a short period. Demerits. This method requires complex mathematical calculations. This method may be affected by the cyclical variations. Ratio to moving average method. This method is otherwise called as the percentage of moving average method. It is the most commonly used method for measuring seasonal variations. The following procedures should be adopted for measuring seasonal variations in this method. 1. The seasonal variations should be eliminated by taking a centered moving average with a period of 12 months, if monthly data are available. If quarterly data are available, a centered 4-quarter moving average must be used. These moving averages will also eliminate irregular movements. 2. Calculate the ratios of original data to the corresponding moving averages. It should be expressed in percentage, i.e. 3. These percentages are then arranged by months and the average for each month is calculated. The total of these averages should be equal to 1200. If it is not equal to 1200, then each average value should be multiplied by. If the periods represent quarters, the total of the 4 averages should be equal to 400. If it is not equal to 400, then each average values should be multiplied by. In illustration 14, it is required to find out seasonal indices through the ratio to moving average method. 7 columns table should be prepared. In first column year should be written. In second column quarters should be written. In the third column variables as given in the illustration should be written. That is 110 divided by 4 equals 27.5. Like that, all values should be calculated. Then in the fourth column 4 yearly moving total should be calculated. That is 5 plus 6 plus 4 plus 10 equals 25. Then 6 plus 4 plus 10 plus 7 equals 27. Like that, other values should be calculated. In the fifth column 2 yearly moving total should be calculated. That is 25 plus 27 equals 52. Then 27 plus 31 equals 58. Like that, other values should be calculated. In the sixth column moving average for 4 is calculated by dividing the values in column 5 by 8. Moving average percent is calculated as actual value moving average x 100. For third quarter of 2013 equals 46.5 x 100 equals 61.5. Calculation of seasonal indices. Total of average equals 97.05 plus 120.7 plus 48.6 plus 135.15 equals 401.5. Since the total is not equal to 400, an adjustment is done by multiplying each average, that is 400 by 401.5 into 100 equals 96.7. Like that, all values should be calculated. Merits. 1. It is the most widely used method for calculating seasonal variations. 2. The seasonal index calculated under this method does not fluctuate like other methods. 3. This method won't be affected by cyclical variations in the calculation of the seasonal index. Demerits. 1. It is not possible to calculate seasonal indices for all the months even though the data are available. 2. In this method, the values of the months at the two extremes are left out. Link relatives method. It is the most difficult one among the methods of measuring seasonal variation. The following are the important steps for calculating seasonal variations under this method. 1. First of all, calculate the link relatives for the given values for different seasons. It can be calculated as these link relatives, link each month to preceding month, or link each quarter to preceding quarter. 2. Arrange the link relatives by months or quarters. Average value of the link relatives for the season, months or quarters should be calculated, on the basis of mean or median. 3. Convert these averages into chain relatives on the basis of the first season, month or quarter. The chain relative of the first quarter will be equal to 100. The chain relative for the second quarter is stated here. The chain relative of the third quarter is stated here. The chain relative of the fourth quarter is stated here. 4. Then calculate the chain relative of the first quarter, for correction. The difference between the chain relative of first quarter taken previously and calculated now should be divided by the number of seasons. The resulting figure should be multiplied by 1, 2 and 3 respectively. Then the product so obtained should be deducted respectively from the chain relatives of second, third and fourth quarters. These are called the corrected chain relatives. 5. The corrected chain relatives should be represented in percentage to give the seasonal indices. In illustration 15, it is required to calculate seasonal indices by link relatives method. Sales for 5 years on the basis of quarter are given. 5 columns table should be prepared, and in these columns variables based on the illustration should be written. Calculations are shown in rows. Hence, 3 rows at the end should be added. Of this 3, in the first row, chain relatives should be calculated and the basis of calculations are stated there. In the next row, corrected chain relatives should be calculated and the basis of calculations are stated there. In the last row, seasonal indices should be calculated and the basis of calculations are stated there. The correction factor has been calculated as follows. Chain relative of the first quarter, on the basis of first quarter, equals 100. Chain relative of the first quarter, on the basis of the last quarter, equals 93.3 into 181.3 divided by 100 equals 169. The difference between these chain relatives equals 169 to 100 equals 69. Hence, the difference per quarter equals 69 divided by 4 equals 17.3. Seasonal variation indices have been calculated as follows. Nonlinear trends. Nonlinear trend is a measure of trend value by taking into account of the future value of the phenomenon under study. But the linear trend is concerned with the measure of the value of variables in future period, by taking into consideration of the increase or decrease of the variables over the period of past few years. According to linear trend method, the variable in the future may increase or decrease on the basis of the same rate of increase or decrease in the past periods. But it does not take into account the long-term growth of an industry. Hence, the nonlinear trend is a measure of trend value by taking into account of the long-term growth of the industry. Nonlinear trend can be obtained with the help of second-degree parabola. The equation for the second-degree parabola is y equals a plus bx plus cx2. The values of the constants, a, b and s can be obtained by solving the following 3 normal equations. I equals na plus bax plus cx2. Axi equals ax plus bax2 equals cx3. Ax2y equals ax2 plus bax3 plus cx4. In illustration 16, the annual percentage of increase in a sales of a company is given. It is required to fit a parabolic curve to the data and also to estimate the percentage increase for the year 2029. 8 columns table should be prepared. In the first 2 columns, values is given in the illustration should be written. In the third column, deviations year should be written by considering the year 2022 as base. That is below that minus values with 1 different and above that positive values. In the fourth column, xy should be calculated. In the fifth column, x square should be calculated. Next, x square y should be calculated. Then x cube and x raise 4 should be calculated. Sum of values in all columns should be calculated. On the basis of the data derived from the above table, parabolic curve to the data and also to estimate the percentage increase for the year 2029 are calculated. Shifting the origin. It is possible to shift the origin of the linear and nonlinear trend equation towards backward or forward. When the base is shifted forward, in the place of x, it should be x plus k, where k is the number of years from the original base to the new base. When the base is shifted backward, in the place of x it should be x, k. Hence, the new trend equations for shifting the base are y equals a plus b x plus k and y equals a plus b x plus k plus c x plus k, 2. Illustration 17. When the trend equation, y equals 20 plus 2.5x with 2021 as base, find the trend equation with 2024 as new base. Solution. Y equals a plus b, x plus k, k equals 2024, 2021 equals 3. Y equals 20 plus 2.5, x plus 3. Y equals 20 plus 2.5, x plus 7.5. Y equals 27.5 plus 2.5x. Illustration. 18. The trend equation is y equals 50 plus 10x plus 3x2. Origin is 2019. X unit equals 1 year. Shift the origin of the equation to 2024. Solution. K equals 2024, 2019 equals 5. Y equals a plus b, x plus k plus c, x plus k, 2. Y equals 50 plus 10, x plus 5 plus 3, x plus 5, 2. Y equals 50 plus 10x plus 50 plus 3, x2 plus 10x plus 25. Y equals 50 plus 10x plus 50 plus 3, x2 plus 30x plus 75. Y equals 175 plus 40x plus 3x2. Deseasonalization. Deseasonalization of data means elimination of the seasonal effects from the given values. It is assumed that seasonal fluctuations will not occur in future. It can be done for the multiplication model as well as addition model. Deseasonalization of data for multiplication model. Deseasonalized data is well presented here, where O represents any observed value, S represents seasonal variations, I represents irregular variations, T represents trend value, S represents cyclic variations. Deseasonalization of data for addition model. The deseasonalization data can be calculated by deducting the seasonal variation for the observed value. Deseasonalized data equals 0, S equals T plus C plus I. In illustration 19, it is given the seasonal indices of profit of a company. It is required to find out the expected profit of the company in the remaining quarters, if the profit of the company in the I quarter is Rs. 54,000. Profit in I quarter equals 54,000 rupees. When there is a seasonal index. The normal profit when there is no seasonal effect equals 54,000 x 90 equals 60,000 rupees. Hence, the estimated profit for other 3 quarters can be calculated, and the calculations are well shown here. In illustration 20, it is given the seasonal indices of sales of a company. If the estimated average monthly sale of the company is 30,000 rupees, is required to find out the monthly sales budget of the company. 4 columns table should be prepared. In the first 2 columns, values is given in the illustration should be written. In the third column, seasonal effect should be calculated by dividing the values in second column by 100. In the fourth column, estimated sales should be calculated by multiplying the values in third column by 30,000. Exercise of the chapter are presented as follows. Please subscribe MWN.com. Exercise of the chapter are well presented. Please subscribe MWN.com.